I've put into a sequence. That may look really confusing to you. You may say, all right, how do you know that? Well, because I've excavated every single one of those things in order, and I have placed them into stratigraphic order. Now, like I said, this can be mystifying to you unless you're really knowledgeable and spent a lot of time analyzing the pottery types or the stone tool types or the metallic types. But you can do this. And I've got a slide that says cultural dating, and it has a bunch of Mercedes-Benzes on it. And they're jumbled up. And I've picked Mercedes-Benzes from the middle of the decades, going back to 1955, and then 65, 75, 85, 95, 2005, and 2015. And I want you to just take a look at that and see if you can put those in order. You probably can, or you can come pretty close. You can tell what the earliest one is. These are all basically the same car. They've just gone through stylistic changes. And you, because you are knowledgeable enough about the culture that you've come from, that you can order these. It's the same principle in archaeology. It's just that archaeologists have come to familiarize themselves with these ancient cultures and their stratigraphy. So their relative dating, I can take a look at a piece of pottery and say, I know when this dates to. And I know that it's earlier than this. So the next one actually, the next slide has that ordered, and you can see, check to see if you got it right. Okay. Now this can be done in your book on figure 118. You can see that the left-hand side shows types of gravestone designs, and on the right, shifts in recorded music technology. And this shows the frequency from each of these time periods of these stylistic objects, right? So you see that trends and style and preferences, they have a peak period. And we call these a battleship curve. So it starts off, the origin of some style is down here, it gains popularity, it has its peak period, and then it starts to drift off in popularity. And that may overlap with the start of another type of artifact that is a competitor to that other artifact. So vinyl records start here, they gain in popularity, and then as cassettes start to build, vinyl records start to peter out. And cassettes come in, and then CDs come in, and now we're on to all sorts of digital media. But the point is that these artifacts that are created, they have periods of introduction, they have a peak popularity, and then they start to peter out. And so if you put these side by side, you can see that the peak period of vinyl records was 1978, the peak period of cassettes, 1988, and the peak year of CDs was 1999. And so if you find a CD, you know that it can't be earlier than the earliest CD. So it can't be earlier than, let's say, 1985 or whenever that was invented. And a cassette can't be earlier than the first cassette. But it's unlikely that you're going to get a cassette tape after a certain date because it's already then been superseded and replaced by others. It's not impossible, but it's not part of its peak popularity. So that's great. Relative chronologies are terrific. They take our stratigraphy and all the objects in it and then put it into an order. But that's not a calendar date. How long ago were those things happening? Well, we enhance our understanding of relative chronologies by inserting absolute chronologies to try and fix those strata, those time periods, those dates. These are stated, absolute chronologies are stated in terms of calendar years, or usually before present. And for technical reasons, present day is 1950. That's because Willard Libby, who came up with the concept of radiocarbon dating, did so in 1955, and so they had to fix a date that was present, and that is 1950. So they decided on 1950 If he had only invented radiocarbon dating 50 years later, we would have made it 2000. It'd be a lot easier. But lots of scientific methods can be used to give us a date, a calendar date looking into the past. And in most cases, when I've just mentioned radiocarbon dating, that can only be done directly dating something that was once alive. So you can't radiocarbon date a stone tool. You can maybe radiocarbon date some organic material that's still clinging to it, but you're not dating the stone. And in fact, if you were to date the stone, you would be dating the geological processes that formed it probably millions of years ago. So that's not what you're interested in. You want a person who finds a stone that's millions of years old. You don't care about when the stone was formed. You want to know when the person who used the stone was making the tool. So dating the stone doesn't help you, right? You want to date something, be able to get an absolute date on how long ago did that person live that made that stone tool. So you can date the stratum itself. That's one method of doing it. For very old contexts, that's one of the best methods. And there are radiometric means of dating. Some things like potassium degrades into argon, called potassium-argon dating. And this can be done on millions of years old deposits. And you're dating the soil itself. Also, luminescence dating can be done on soil deposits that date the last time ultraviolet light hit it. So the last time this surface here was exposed to the sun, it then got buried, trapped there. We actually can measure how long ago ultraviolet light hit that surface and was buried. Kind of tricky to do that, and it's not perfect, but it does give us an absolute date. Things like dendrochronology is something that if you have charred wood or even preserved wood, you can actually measure the tree rings in it. And we have now, going back 10,000 years, overlapping tree rings that give us a dendrochronological record that can actually give us almost to the year dates for certain when a particular tree was chopped down and charred and preserved. Paleomagnetic dating is sort of a broad brush way of verifying other dating methods, because it's not a particular time and place, but the poles, the north and south poles, the core of the Earth swirls around, and it's iron, and that's where our magnetism comes from. Sometimes the poles shift around, and the north is the south, and the south is the north. The planet doesn't move anywhere, but the center of the magnetic polarity does reverse. And this gets embedded in certain types of stones and strata, and if it will actually, but then it will flip back around, and if you can measure the paleomagnetic orientation of this, it can verify that actually you're in this slice of time where the poles were reversed. Obsidian hydration dating also is a way to get dates on the formation and of obsidian that is a type of volcanic glass that was used as chipstone material. It's actually extremely sharp. I'll talk a little bit more about use of obsidian in later lectures. And then, of course, coming back around to radiocarbon dating. For more recent, up to about 80,000 years old deposits, this is one of our primary ways of dating materials. But as I said before, whatever you date has to have been at one point living. Radiocarbon is in you right now. You have carbon-14 that is radioactive. You are constantly replacing it. Every time you breathe air, you are bringing in carbon, and carbon is basis of all life, right? Carbon atoms are extremely clingy. They like to just sort of cling on to other things, which is why life finds this a very useful molecule or atom, the carbon atom. But there are different isotopes of carbon, some of which are unstable. And unstable carbon wants to move to a stable form. So carbon-14 is an unstable form of carbon that wants to transform from carbon-14 into nitrogen-14. So it will lose elements and it will decay unless you're alive and you're constantly replacing this level of carbon-14. So rather than carbon-14 decaying in your body, it is being constantly replaced because you're living, you're alive, your body's doing this. Once you die, once anything dies, a tree, a weed, a rabbit, a cow, a whale, anything, when any living thing dies, it stops the process of replacing this unstable isotope of carbon. And then the carbon starts to do what it does naturally, which is decay, to become radioactively decay into its stable form of nitrogen. And what Willard Libby identified is that it does so at a constant rate. That's really important because once something dies, then the decay process starts, and because that's a constant rate, it's like a stopwatch starting. So once a creature dies, boom, radiocarbon starts to decay, carbon-14 starts to decay. And we know that it decays at a rate of 50% for every 5,730 years. And then it has another half-life, and another half-life, and another half-life. After a certain point, at about 80,000 years or so, there's so little radiocarbon in anything that we can't actually even measure it anymore. So radiocarbon dating becomes useless at that point, and we've got to use another method of absolutely dating. But what that will tell you is that how much carbon-14 as opposed to nitrogen 13 that's in a body, it will tell you how long this thing has been dead. So any organic remains, that can be a seed. In fact, that's really very useful because seeds are from annual crops or annual plants, that if you find a charred seed in a stratum, that means it probably came from the year that it was deposited. A grain of wheat, if you are cooking some wheat over a fire and a grain falls into the fire, we find it later, we can radiocarbon date that one seed, and it's dating to that particular year that it grew and died and became charred. And how long ago was that? Well, however long the radiocarbon dating method tells us. So it will tell us how long ago this thing died. So it's the combination of the excavation of stratigraphic layers, the objects and ecofacts, the artifacts and ecofacts in each of those strata that give us a relative chronology, and then the absolute dating that can fix each of these layers in time, so we then can create a chronology. There's other ways to absolute date things. A coin can be pressed in a particular year, but as we all know, just check your pockets. If you've got a coin from the 1980s, does that mean that today is 1980? No. So we have to be careful about when the objects and art ecofacts that we've got in our strata date to. We have to be very careful about that. And this has some nuanced factors in it that I won't go into right now, but this is the job of the archaeologist, to try and untangle all of this complex absolute and relative chronology, stratigraphy, survey, all of these processes. And these are all brought together to create a regional or even global understanding of what life was like at particular times in the past. These can be done through comparing. So you have things at one site that tell you a particular story. Is that the same at another site? Is it the same within the same site? In fact, if you dig one trench, is that one household that you've just dug, is that the same as another household? Or maybe that was a workshop that you were digging and not a household at all. Intra-site comparisons can tell you a little bit more about the structure and the relationships between different contexts within a site. And then you do that on a larger scale. Inter-site comparisons are between two or more sites that can be used to carry out regional analyses of past societies. And then you can look at interregional studies and more global questions. So these time-based comparisons can be synchronic. They can look within a single period of time to understand the way that a society or a larger regional society behaved at any given point in time. But it can also look at change through time. And in fact, archaeology, more than anything, does that really well. Is look at comparisons across different time periods to see how things have changed. How is patterns of human behavior changing through time, and how can we understand that? Okay, so that brings us to how you do archaeology. There's a lot more to talk about there, which I'll probably come to, but that just provides the fact, the little pixels of data. What we also then need to understand is, where do we put all these pixels? How do we create a mosaic that can provide us a picture of the past? Well, we got to use our brains a little bit. We've got to understand the way humans operate. We've got to understand systems and societies. So that will take us into the theoretical realm, which is what we're going to come to next chapter. So I'll see you then.